Good evening, everyone. This is Henry from STEM Tutoring, once again attempting to serve as your wise old math sensei. Today's problem comes to us courtesy of a few Marine officer candidates who are studying for the SAT, and they asked me, how could we solve this problem in the easiest manner possible using Desmos if we see this problem on the actual SAT? So suppose the problem asks you, if you take the line 9x minus 10y equals 19, and translate it down 4 units, you shift the whole line down 4 units, what will be the x-intercept of that new line after you've shifted it down? So I use Desmos to graph the original equation, 9x minus 10y equals 19. That's this red line here. We can see that the y-intercept is negative 1.9. And over here, we can see the x-intercept is 2.11 repeating. It stops after 5 digits, but it really is 2.1 going on forever, where the ones just continue forever. So, first of all, to find the slope of this line, slope is rise over run. So we'll compare these 2 points since they're so convenient. If we go from negative 1.9 up to 0, that's a rise of exactly 1.9, the numerator here. If we go from 0 to 2.11111, well, that's a run of 2.11111. That's the denominator here, rise over run. And Desmos graciously tells us that the slope of this line is 0.9. So now we know the slope, we know the y-intercept, negative 1.9. We can write a similar equation for this line in y equals mx plus b format, because we know the slope m and we know this y-intercept b. So we can rewrite this as y equals 0.9x minus 1.9. And you can see if I hide this line, it's the exact same line. I wish I could choose a different color here. Let's see here. Okay, too bad I can't choose a different color. Is there a way to choose a different color? Okay, I guess not. So, but you can see both red lines are the exact same thing. I can hide this line. I can hide this line. They're exactly the same. So now it's in y equals mx plus b format. To shift the line down 4 units, well, the y-intercept, if we shift it down 4, that's minus 1.9 minus 4, which equals negative 5.9. So if we shift the line down by 4 units, the new y-intercept should be negative 5.9. So we can write a new equation for the line, y equals 0.9x minus 5.9. The green line has been is the red line that's been shifted down 4 units. The new x-intercept is over here. 6.555556, but really that should be 5 repeating on forever. Desmos just rounded up the last 5 to a 6. But there you go. That's the easiest way that I can think of to solve this potential SAT math problem using Desmos, because thank goodness these days when you take the SAT, you can use Desmos. In the old days, it would have been much more difficult, and that more difficult way is how I was taught. So when the student asked me, what's an easy way to solve this using Desmos, I actually had to give it some real thought. But after giving it some thought, this is my interpretation of the easiest way that I can think of to solve this SAT math problem using Desmos. So for those of you studying for the SAT, whether you're a Marine officer candidate or whether you're a high school student trying to get into college, I hope you found this helpful. If you did, I would certainly appreciate it if you'd like and subscribe to my channel. And also, shameless advertising plug here, I am available for hire as a private tutor. I tutor both math and science. Here's my website. Check it out at your leisure. Thanks for watching. Have a good evening.